lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs, relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
All right, what's up, everybody?
My name is Jeff.
All right, let's make sure all my chat stuff's working today. I apologize. We were originally going to stream 30 minutes ago, but like originally we were going to stream 30 minutes. Yeah, right away, Jeff.
My name is Jeff.
I got you right away. So I appreciate you guys being fluid with me. My scheduling has been kind of all over the place. I had to go get a haircut before my trip to Europe, and that ended up taking 3 hours. It's only supposed to take 2, but whatever. I have a wedding, so I have to make sure all this gets trimmed. For that, and then what else? And then I also need to pack. I still haven't packed yet. But my flight is like at 6 o'clock tomorrow morning. So anyways, might be a little bit shorter of an office hours than usual. But I appreciate you guys being here. This will be the last one of the month.
My man.
Because I will be gone for probably 9 days, maybe 10 days with the jet lag. So we'll be back probably June 1st. We'll do streams again. And then we'll start the summer. Summer's always a fun time. Because yes, I know a lot of you guys don't have school, you don't have classes, which is great. Like, enjoy the summer, have fun. Some of you guys are taking summer classes though, and then I know some of the international people in Australia, technically, like it's not their summer, it's their winter. But so what we end up doing is we'll run special events like summer camp, and then I will start teaching my online course at UCLA at the end of June, or I think like June 20th, so maybe it's like mid-June. So that will take up a lot of the streams. And again, you're more than welcome to come by to those. Those are going to be really fun. If you want to learn physics for free, which is similar to like it is literally a college level class that I'm teaching. You're more than welcome to come by. You can still earn channel points and all that fun stuff. What's up, Potato Media? So yeah, I'll make an announcement in the Discord either later tonight or when I'm at the airport tomorrow. But just kind of explaining everything, because I will be gone. I will still have cell reception. It's not like when I go to Burning Man, and I have no reception for like 2 weeks, and then I just kind of really hope that my mods and everyone just keep things from like burning down to the ground.
Oh no.
But, so I will still have reception. I will still be, quote unquote, like reachable, but I'm not sure how active I'll be able to be. But that being said, we have an awesome team of mods, and all sorts of other admins and great people in the server. So if you have any questions and stuff, right, you can talk to Sensation Black. Sensation's one of our top admins. And then we have all the student class reps, all sorts of awesome people. And then, yeah, all the people who also help out in my Discord with homework questions, even when we're not streaming. I love all you guys as well. So things persist even if I'm not there. Just the live streaming will be non-existent. But we have other people that are streaming, so make sure again that you go check them all out. They're on our calendar here. So looks like Zach is streaming right now, and then he'll be streaming the rest of the week. Eric will be on Friday. Penn Center's back in the mix. That's great. And then next week, also Justin's going to start streaming again. Cool. And then I heard some rumors that we may be getting another new streamer with Breasticles. I'm super hyped for that.
Those rumors were correct.
Those rumors were correct. Yeah. Breasticles, make
Yes.
sure you like DM me and stuff before like you actually do it, because I want to make like a huge announcement for you. Like we're gonna like
I
hack your
will.
stream.
I will.
Good.
Bet.
Bet. So yeah. Let's see. Yeah, other than that, no crazy new news. New news. I'll have a big post about all the fun things happening for the summer. Last year, and actually the last couple of years, we do a thing called like summer camp, which is kind of like a virtual, it's a virtual summer camp, because we obviously can't have a physical summer camp here on Discord. But what we do is we have a bunch of little activities and mini challenges, and we do video game tournaments, chess tournaments. We have a talent show. We have all sorts of like fun stuff we do for summer camp. And at the end, we give out a really big prize. I think last year we gave out a Nintendo Switch 2. A couple years prior, we gave out a laptop. And then we also gave out an Xbox and a PS5. I think our first year of doing summer camp, which was 5 years ago. So let me reach out to our sponsors with what we're gonna do for this year's prize. I'm trying to think like what's the new hot thing that's out. Last year it was definitely the Switch 2 that it just came out. I don't know. We'll figure it out. But that usually starts in like July. Once I get the UCLA class rolling and it's on autopilot, then I can start focusing on us doing more fun shit with summer camp. And then that'll go until probably end of August, and that's when Dr. Gold leaves for Burning Man. And then I'm gone for 2 weeks. And then we start the next semester. So yeah, MacBook Neo. Oh, that's actually a great idea. I actually really like that. Yeah. We were talking about the MacBook Neo yesterday with Tuma and Matham. Yeah, it's actually a really solid laptop. And great for students, and I could probably finesse some sort of sponsorship for it, because it is like it is definitely a student thing. Let me talk to Apple, see what they say. That's a great idea, Vavo. I like that. It's a really good idea. A MacBook Neo. Yeah, and it's not terribly expensive, right? I can probably get one for around $500 with discounts. Maybe I can get some non-profit discounts on stuff. A 2026 RAM 1500 TRX. That's hilarious. Yeah,
I think you could swing that.
I think I could swing the
that either
TRX.
way.
Isn't that like $100,000, dude, for the TRX?
I think it's more. It used to be like $100,000.
Yeah, it used to be like
$100K.
100K.
Like discontinued it because of like, I don't know, like.
So it's funny. We talk about the TRX. I saw one in action. My first year at Burning Man was 2023, which was the mud year, which is when it rained and it flooded and everyone got stuck.
Mm-hmm.
But some people were very determined to get out. Like we were told just like stay, shelter in place, do not try to drive because the mud turns to concrete and your car will get stuck. But some people said, yeah, fuck that. Like I'm getting out. And there's this video of this person in a Ram 1500 TRX carrying a trailer, just fucking boosting, dude.
Those things are beasts. I worked on one once. You got like a solid, like probably, I'd say 3/8 to a half inch, like massive ass giveaway. Nice. Or like some meaty trucks, and they're fast.
Meaty trucks,
They're fast and they're loud. They're awesome.
They're dope, yeah. Thank you, YX. YX says, hi, your videos are super helpful. Thank you. Let me know which videos are helpful. We have been getting a bunch of hits on them, I guess. This always happens towards the end of the year when people are taking finals. They find our videos because they're looking for, hey, how do I do... yeah, look at all these comments we got. Brother, you saved my ass from the exam tomorrow. Thank you very much. From Lebanon. I dated a Lebanese girl once. Yeah, Lebanon's dope. I'd love to visit, but apparently it's not a really great place right now.
Did her first name happen to be Mia?
No. Man, what was her name? Her name was Amal. ML or something, I don't know. But
Oh.
what would you say? Lydia? You say Lydia?
Mia.
Oh, Mia. Is Mia a Lebanese name? I didn't know that was.
No, but there's a really famous Lebanese chick.
Oh,
who
stop.
actually got the parents' name.
Oh,
She's Palestinian, not Lebanese. She's Palestinian.
I thought she was Lebanese.
Pretty sure she's Palestinian. Anyways, we know what we're talking about.
I think she's Lebanese
Okay.
because she like went on a rant about what was happening in Lebanon and Palestine and all that.
Yeah.
But she was saying her home country like it was.
Like it was
Lebanon.
Lebanon. Okay, yeah, maybe it was. Maybe it was a girl
Not
named
sure.
Mia. So yeah, I need to make more of these videos because they do help you guys. It's on my list. I gotta have like a big reprioritization of my life. But anyways, yeah, I'm glad the videos were helpful. What's up, Kashuki Techno? Good to see you too. All right, enough yapping from me. Let's go help you guys out with some math and science questions, and let's start the stream. All right, welcome everyone.
Beirut, Lebanon.
What's up? It was Beirut. Oh, she is from Lebanon? Okay, I was wrong.
From Beirut.
Okay, she's from Beirut, yeah. Our friend Mia. But yes, welcome everyone to Actual Education Office Hours. My name is Dr. Gold, the stream that helps out math, homework, science, homework.
My name is Jeff.
With Jeff. All right, let's see what we got. I'm going to delete all these pages because we don't need any of this right now. Still here, Jeff. Jeff says, I'm still here, dog. Okay. And I think we're live on... yes, good. We're live on TikTok. I can't get my TikTok chat to work for whatever reason. It'll figure it out eventually. Anyways, so if you go to the website actualofficehours.com, we have a queue here. Here's all the questions people have submitted so far. Ooh, we got some fun ones. Some 8 out of 10s, 5 out of 10s, 7 out of 10s. Cool. What were you saying, Sensation? What's up?
I don't know.
I don't know.
Oh my god, bro. Hell no.
All right. Let me.
I wasn't saying anything about that equilateral shape in the middle of China.
Equilateral shape in the middle of China. Is that
Did
Nepal?
anything happen to happen with large vehicles that happen to have armored plating?
Oh, that shape. Oh, sorry, not Nepal. Yeah, I know what you're talking about. The one with the tanks.
Yeah, that one.
Yeah, that one. The one with the
That
tanks.
one. Nothing happened there.
Nothing happened there. All right, let's choose one.
happened.
Let's go gambling.
Probably gonna be Hello Part 2. I'm guessing it is you. Yep. You technically submitted when I was gonna start the stream, so I'm gonna count this as like it wasn't early. It's just a fuck up on my part. But let's see if I can even do this. Kachuki Techno, because I may not be able to. Ugly question, but maybe fun. Yeah, sounds like my Friday nights. Okay, let's see. For a real number alpha, no, dude, alpha. I gotta draw alpha again. I don't like drawing alpha. These alphas haunt me, dude. Yeah, no, it's CX. This is how I draw alpha. This is how I draw alpha. I'm slowly converting. I know you guys really hate my alphas. I'm figuring it out. There you go. Okay, that better. Okay. Let alpha be a real number and let the set alpha denote the greatest integer less than or equal to alpha. I think this is called the supremum in like real analysis. It's called the supremum. It's called the floor. Oh, the greatest integer. Yeah, less than or equal. Okay, yeah, I'm dumb. Yeah, sorry, this is not the supremum. The integer part makes it a floor function. Interesting that they do this, though. Isn't this usually floor? This is usually floor, I thought. Thank you, Sensation. Yeah, I need help with that. I really do.
No, that would be, in this case, the supremum. Because the supremum is the least upper bound.
But
so in this case,
is the
if we're talking
integer part?
about...
Is the integer part make it a
so
floor?
when we talk about like bracket alpha as alpha for a real number. Never mind.
Right. If it was for an integer, then yes, I think we could call it the supremum.
Well,
Yeah.
so for an integer, if you talk about I'd seen set and I jumped too quickly. I was
Jumped the
thinking
gun.
of
Shit, not good.
yeah, I was saying sometimes we notate bracket and then a integer number as being
Mhm.
the set containing like 1, 2, 3, 4, all the way up to that integer number, in which case alpha would be a least upper bound, but if it's not in this case.
Yeah, exactly. There you go. Supremum of S is the smallest number that's greater than... the smallest number that is greater than or equal to all the elements of the set. Oh, so it's not in the set, the supremum?
Not necessarily. It's
Oh, interesting.
supremum's just the least upper bound. It's just a fancy way to say it.
Least upper bound. Okay. For the finite set S, those functions are interchangeable, but basically it's a floor. Thank you, Kachuki. Kaushik. Sorry, Kaushik. I was saying your name wrong. Kaushik. I'm probably still saying it wrong. Okay, consider the functions f -3, 3 maps to -infinity, infinity, and g -3 to 3 maps to -infinity to infinity. Defined by f of x is equal to this nasty function. And g is equal to this also like nasty function. But I see the difference here. This one has a floor in front of it, and this one doesn't. But then this one has a log base e, and this is there's a lot of stuff going on here. Okay. Let A be the set x is in the whatever -3 to 3. Oh, I think I see what it's saying. If you go from -3 to 3 in f, it maps to -infinity over infinity. And how would that work here? Oh, I see. Maybe this log base e... No, because this would always be positive, right? Sine squared would always be positive. So the lowest you can get is the log base e of 1, right? Which is just 0. No?
Yeah, but you have a x cubed in front, so you can produce negatives still.
But x cubed can only go from -3 to 3. How does that map to -infinity to infinity? Unless I'm not reading this right. I don't know.
No, that is what it's saying. It's saying that the domain is -3 to 3, but
how's the range -infinity to
trying to-
infinity? How the fuck would that happen?
Oh no.
I'm trying to think of a good way to explain it, but it is
It is true.
possible.
The range can do
It is
that.
possible.
No. I'm
Yeah,
asking
like
chat.
so, like
Tell
an
chat.
example of that is right.
This
So
is
when we
possible.
talk about like the size of a set and cardinality, we talk about a bijection.
Okay, well,
and
you said
so
two words I don't
technically-
understand. What's bicardinality, and then what was the other one?
Cardinality and bijection.
Cardinality and bijection.
Cardinality is basically the size of a set, and a bijection is certain conditions, right? So it's injective and it's surjective.
Mm-hmm.
And basically, the point is that if you can define a function that goes from one set to another and there's a bijection, the cardinality of it has to be the same, i.e. the size has to be the same. And so an example of that is we could choose 0 to 1 to the real numbers, so -infinity to infinity, and produce a bijection that shows that what's it called? That 0 to 1 has the same cardinality as -infinity to infinity. So the size of the set from 0 to 1 and -infinity to infinity is the same size. So by that merit, it's also possible that we could have -3 to 3 going to -infinity to infinity.
I
If we
see.
choose our functions properly.
I
Like
s-
kind of
okay.
how our tangent goes from 0 to infinity in its range
Yeah.
on the interval of 0 to pi over 2.
Right. Yeah, I understand that one. Yeah, I think my main concern was I was trying to figure out what value of x between -3 and 3 would map to anything close to infinity, and I guess that's the difference between a function being onto versus
Yeah, so onto
just saying
is
that-
surjective.
yeah. Exactly. Okay. Wait, let me see. What is this chat dynamic grid? This is just an observation. When I was in school in the 90s, I was in school in the 90s. I reasoned that math was unnecessarily difficult for a known reason. One thing I noticed was that the publishing date was 1955. There's certainly a better way to describe this material, namely publication is reviewed. Okay. I think I understand what you're saying, dynamic grid. I think you're saying that the jargon hasn't changed over the last 50 years, and that's starting to confuse people, which I agree. I mean, even myself, I get confused with this kind of all these like fancy math terms they start saying.
or conversely, you're all becoming stupider.
True, that too, Sensation. We're all just getting dumber.
Because it doesn't seem to be a problem for fucking anyone else.
I know, but the world is different, Sensation. There's too much information out there.
The world whom?
The world hoopst. The world hoopst.
Fucking
It's-
Jesus.
I know. It's codomain actually, which is eventually range for bijective functions, e.g. f of x equals x cubed. No, Nathan, this is not Calc 1. This is not Calc 3 or Physics 1, unfortunately. This is I don't even know what I would class. What did our thing classify it as? It said it was calculus.
But that's,
Fucking
yeah,
wrong.
sometimes people
It's
call
so
like real analysis a form of calculus. Some places mix analysis into calculus.
I agree, Jeff. There are better ways to teach it. Yeah. Or more, we have to adapt with ways that people ingest information these days, you know? So, why isn't the material consolidated into a legend with questions to follow? I mean, I'm sure there is a legend somewhere here, Dynamic Grid, for this. There probably is a glossary that we could look up for this. It's just part of the process of learning is discovering those things for yourself and having the information be kind of an adventure. If it's all presented to you like easy peasy, I don't think your brain really appreciates it as much. Like, I think the process of looking things up and figuring things out is similar to the process of picking up weights and lifting them. You know, you're building up muscle doing that. So, yes, an ontology of math. What's up, Sensation? What's up?
You've just contradicted yourself there.
Yeah.
We have to temper the way in which people absorb information. Oh, but you have to lift weights in the same way.
True.
Do you see the contradiction?
Yeah.
There is the way things need to be done, or have to be done, because of, well, biological construct.
Correct. Yeah.
Which would include the way in which you absorb information.
Yeah.
Dumbing shit down for dumb motherfuckers doesn't help everyone else.
Myself included. I think it helps. I think it helps to not scare people off too quickly. I think if we give like an on ramp, we need an on ramp.
Think also like when
That would be why we have
when
different
you
classes.
dumb stuff down. I think there's a difference between dumbing it down in the sense that you're reducing jargon and making it sound really scary, right? Dumbing it down in a way that you can understand it without, you know, needing to know a bunch of jargon and terminology. And then there's dumbing it down so that you're like making it so a baby could understand it with zero
teach it to me like I'm 3.
mathematical understanding. You know, there's a difference between dumbing it down so that people can understand it and dumbing it down in an ineffective way. And I think people tend to go to the ineffective way because they don't really understand what they're trying to communicate. I think if people understand what they're trying to communicate, they should be able to dumb it down in a way that someone could easily
And it still retains the
actually truly
information.
understand it.
Yeah, and it still retains the meaning. Yeah.
What is a dictionary?
What is a dictionary? Yeah. But even a
Do you see
dictionary
where I'm going with
sometimes
this?
a dictionary sometimes uses like kind of complicated words to describe things. Yeah.
Well, not because a word exists separate from its.
Yeah.
An orange
Unless,
is not, a fruit is not necessarily always an orange.
But the funny one is if you ask for like what the definition of a tensor is, it says a tensor is something that behaves and acts like a tensor. You're just like, excuse me.
That's on
out of here. Get that out of here, dude. Anyways, okay.
I feel like that's a horrible definition too, because I always just describe it as 3D matrix. Call it a day.
Dude, I'm pretty sure this is the
higher
definition
dimensional
of
matrix.
I've seen the jokes where they say it's like it behaves and acts like a tensor. Okay, maybe they actually like have some real things in here. Okay, but anyways, I will try a couple more minutes on this, and then I'm probably gonna pass on this Kaushiko, because this is like way outside of my wheelhouse. I have no clue what this is. I learned today what injective, surjective, and bijective are. These are math words that, again, in my 15 years of teaching math, I've never seen these words. I'm down to learn them, but I understand why this confuses people.
Yeah, they're really big in like discrete math and like real numbers course. Like
exactly.
I had to take a foundations course this semester, and they talked a lot about that.
We can't all teach like Richard Feynman. Yes, bless Richard Feynman. We love Richard
Feynman's the
Feynman.
goat.
Damn logic. He is the goat, dude. He's the absolute goat. I watched some
Do
of
me
your
a
short
favor.
clips for my test tomorrow. Wish me luck. Yeah, good luck on your test, Ayana. Dude, I told you we're getting so many people hitting us up saying like, "Hey, I love your videos," because I know they're all studying for their test tomorrow.
Speaking of test
What's
to
that?
see whether that question is in the JAAA.
Oh, this question? I don't think this is I don't think it's a JEE question. There's no way this would be JEE. Or maybe it is. You could be right.
What did you just say to me? In my 15 years of teaching math,
Yeah.
I've never come across.
I've never seen this. But also this says
No,
mathongo.
but in
What's
fairness,
mathongo?
Yeah, and in fairness, bijective and surjective and injective, it's not like JE level stuff. It's just stuff that unless you're specifically focusing on math major and pure math and analysis, you're not going to see, right? Or
Yeah.
at least unless, if you go into like cryptology, you'll see it because like in encryption, it's helpful to have a the idea of
One-to-one
bijectives.
thing,
If you have
right?
if you have a function that were to have a bijection, you know the size of that, and it helps with encryption. But it's not something you're going to see unless you specifically focus on it, and it's very heavy in like a pure math, like cryptology or analysis type of field. Not really something that you're going to see in like standard calculus or physics math.
Well, I didn't see it either, so
Yeah.
I would still
It
say
was-
it's on the absolute extreme.
It is on the extreme. I'm gonna pass on this question. All right, cool. Just because of time, I'm limited on time today, so anything I can't do or help, I'm gonna pass. But it will still be in our Discord. If you all want to go talk about it and answer it, maybe explain it, you can always go to our Discord and go to the Homework Help channel, and then you'll see. Here's your question. Hello, part 2. Some of them are cool, but some, yeah, I just have no fucking clue how to do this, and that's totally okay. Happens in life. Cool. All right. I appreciate you work on it your free time. Yes, of course, yeah. Let's go spin the wheel. I know there are other people that have finals and stuff. We want to make sure we get them help before I got to go off to Europe. Let's go spin the wheel. Who we got?
Let's go gambling!
Just remember, Europe is not a monolith. You will get your head kicked in if you start playing that game.
Monolith? What's the monolith? Nice job, Lucky Cat. What's the monolith argument?
The United States is a monolith because it is a monolith. Europe is not a monolith, not even close. Each state in Europe is a country in and of itself.
That's true.
And if you even threaten that any given country is part of some monolith like Europe, you'll get your head kicked.
We would want that. What's up, Zach?
The Germans are especially vociferous about that one, which is fucking ironic given the fact that.
Given they tried to take over all of Europe.
Well, no, because I think that the European Union, I think Germany's at the center of it all.
Yeah, don't they? So it's interesting within Europe. So again, technically, like I think the UK is like a part of quote unquote Europe, but it's not part of what they call the Schengen zone. Is that what it's called? Schengen?
The Schengen,
It's a weird term, right?
we have been fucked over by that. Well, so quite a lot of people have been, but
Yeah.
yeah. Because I mean, this is the thing. It's like people.
But that's a German term, is it not? Schengen? The Schengen? That sounds German to me.
Probably.
No. Yes. Okay. All right. Nice. Good. Yeah. Shout out to Zach. Awesome. Good to see you, Zach. Thanks for coming by the stream. Let's help out. Yeah. Pineapple says have an exam tomorrow. Let's do it. Okay. Consider the top half of an ellipse. Y is equal to 1/2 square root of 40 minus 4x squared. Determine the proper standard form equation of the normal to this curve at the point where x equals 1. Graph the semi-ellipse, the tangent, and the normal. A good way to sketch this curve is by using the intercept method. Okay, it's kind of cool. Wait, proper standard form equation of the normal to this curve? What is standard? Is that it's just like slope intercept form? Is it, what's standard form? Sorry, what for just a line?
And that's also a line.
I want to say it's AX plus BY equals C or something like that.
Plus C. I think it's plus
It
C
might
equals
not
0.
be the exact.
I think it's this. I think it's AX plus BY
Yeah.
plus C is equal to 0.
Yeah,
This is really weird, Pineapple. Why the fuck are they asking this from you, dude? Oh, man. Okay. Okay. 1/2. First of all, I don't like this in this form. I would write it this way. So, just to imagine what it is. So y is equal to 1/2 square root of 40 minus 4x squared. Your school and your teacher are always weird. Yeah.
Emotional,
It happens.
damn it.
I would move the 2 over. So I would get 2y is equal to the square root of 40 minus 4x squared. Then I would square both sides. That's what I would do. So that would give me 4y squared is equal to the square root of something squared is just whatever's inside. So that's going to be 40 minus 4x squared. Look how much nicer this is. Move this over. You get 4x squared plus 4y squared is equal to 40. Divide both sides by 40, and you get x squared over 10. So this isn't actually an ellipse. This is a circle, right? No, it's not. Sorry, because it's equal to 1. Wait, no, it is a circle. What the fuck? Wait, I'm not crazy, right? Is this just x? It's a fucking circle.
That's a circle.
This is x squared plus y squared is equal to 10. What? This is not an ellipse. I mean, it's an ellipse with, like, perfect eccentricity, I guess. What's up, Psych? Technical circuit. Yeah, I know technically circles are ellipses. I can definitely help with quadratic functions. This is a quadratic function, for instance. Okay. This has 0 eccentricity. Right. Yes. Great.
Technically not a function, actually.
It's technically also not a function. Yeah. Yeah, because it fails the vertical line test. Okay, this is a circle with radius 10. Radius squared of 10, sorry. Centered at 0, 0. Okay, cool. Yes, Psych, I can definitely help with that. If you want to submit a question to our queue, that's the website, actualofficehours.com. Go hit it up. We'll help you out. Okay, so the normal to this curve at where x equals 1. So, and you don't know derivatives yet, though, right? I don't think they know derivatives.
No, pineapple. I know pineapple knows derivatives. I don't know.
Oh, you do know derivatives, pineapple? Am I allowed to use calculus here? Because I
pineapple
need
is
dy
good.
dx. I need it, I think. Yeah, right? Okay, great. Okay. Yeah, okay, so normal to a curve is perpendicular to the tangent. So, for instance, if you have a curve that looks something like this, and then well, actually, we can actually graph this. Let's just graph this. This is where this probably helps us out, because if I know that the radius is the square root of 10, then I know that I know this is going to be square root of 10. This is going to be square root of 10. This is going to be square root of 10. Don't get mad at my, I'm not drawing things to scale. And then let's see if I can get like a graph, oh, Jesus, no. All right, do something like that. Cool. That's what it is. The curve listed above is better known by what shape? Fucking circle.
Disqualified.
We already know this answer. Okay, pineapple. It's a circle. Or it's a semicircle, I guess, technically, right? It's a semicircle. I really want to get like nosy about it. Okay, so if I want to, so the tangent at x equals 1 will be something like probably this. Let's say this is like x equals 1. This is going to be the tangent. And then the thing that's perpendicular to it, right here, this is going to be the normal. Okay. So, okay, cool. We graph the semi-ellipse. And then let's get the normal to the curve. So let's first get the tangent to the curve. So the tangent is going to be just some y is equal to mx plus b, where this slope here, the slope of the tangent line, is always the derivative of the function. And then this is going to be at x equals 1. So I need to do d dx of this. So dy dx is equal to d dx of 1/2 square root of, and I'm gonna write this as an exponent. It makes my life easier. I'm gonna say 40 minus 4x squared. We could also do like implicit differentiation, couldn't we? We could. It would be so much easier probably to just implicitly derive this. Yeah, you're in 8th grade. All good. All good. Psych Vedix. Yeah. If you submitted it, and don't worry, these questions may look harder. We do easy stuff too. We don't just do hard as fuck stuff. Yeah. And then this is all sorry to the 1/2. Okay. So let's get it. So derivative of this is going to be equal to 1/2. The 1/2 will come out. It's just a constant. And then I have the derivative of something to the 1/2. This is a chain rule pineapple. So I'm going to pull the 1/2 down. So that's another 1/2 that comes down. And then it's going to be whatever's inside here all to the negative 1/2. And then times the derivative of what that thing was. That's how the chain rule works. And so the derivative of this whole thing, okay, well, this part, derivative of 40 minus 4x squared, that's going to be minus 8x. And we have this back. Okay, cool. So then this is a quarter. 40 minus 4x squared to the negative 1/2, all times negative 8x. That's dy dx. Jeff's like me first. Jeff says, hey, which one? Who's it gonna be, Jeff? Jeff wants hello part 3. Okay, all right, fine. It's not as bad as AI says. Okay, great. Okay. All right, and we're gonna do this at x equals 1 because we want to find out what the slope is here at x equals 1. This is what the slope is anywhere for any x between negative square root of 10 and positive square root of 10. But I wanted it at x equals 1, so I'm just going to plug 1 in. And so that's going to get me a quarter. 40 minus 4 is going to be 36 to the negative 1/2, and then this is going to be negative 8. What's up, JC? I'm flying to your island tomorrow, JC. I shall be in your island. You in Sensations Island.
It's 2026. That sounds really bad to say without making it contextually clear that they're from
What do you
England.
What? Wait, I can't.
Flying to their island
I'm
tomorrow.
flying to their island. What's wrong with their island? Dude, what? Am I not allowed to say island now?
I don't know, but it really sounds reminiscent of Epstein. Yeah.
Oh, that guy. Oh,
Yeah.
interesting. Wait, no. This is where like the sensation is gonna be like, hey, wait the fuck? We can't say the word island now.
I don't know. I mean, I feel like we can.
no.
I just, like out of context, it's like, oh, I'm flying to your island tomorrow.
Yeah, no, because England is an island, isn't it? An island? It's an island.
It is, but like,
Can't say the hard I, bro.
Oh no.
Oh my god. Okay, can't say the hard I.
yeah, it kind of makes you sound like you're in the files. When you do that.
Jesus,
Like,
dude.
oh, I'm gonna fly to your
Oh
island.
man, dude. Oh no. Okay, here we go. All right, this is slope of the tangent line. Can't say the hard I, bro. Okay, thank you, guys. Okay, slope of tangent line. Great. Okay, so once we have the slope, then you can find the equation of the line. Well, let's figure out what the point would be here, right? We need the point as well, eventually. Okay, so, and the point is when x equals 0, or x equals 1, sorry. And so that's going to be y is equal to 1/2 square root of 40 minus 4 times 1. So that's going to be, again, the same thing. 1/2 square root of 36. 36 square root of 36 is 6. So it's equal to 3. Okay, so slope of the tangent line and the point when x is equal to 1. So this is your point. It's 1, 3. So do with you will. The tangent line equation, and I assume you know how to like just put things back into whatever form. This would be y minus 3 is equal to negative 1/3 x minus 1. And then the normal line is going to be y minus 3. Remember that normal and tangent are the negative reciprocals of each other. So this would be equal to positive 3 x minus 1. And then you can rearrange it. And so there you go. I think we got it. We got the tangent. We got the normal. And then we can sketch them. And then, yeah, that's it. Cool. And then there's your circle. Does that make sense, Pineapple? It's just kind of cool. Good question. I like it. I appreciate it. Many children on this island. Oh, no, dude. No, JC. You're very welcome.
Yep. I live approximately there.
Approximately there. Good luck finding him. Somewhere next to York.
Have you not noticed already? You haven't noticed, have you?
No.
You see the big road?
I see this big road. Is this like the M85 or something?
I think that's the M1.
M1. You're off the road, so you're off the beaten path. Also, there are no fucking roads here. There are no roads here.
It's the A1M.
Why are there no roads here?
Because you can't build roads there.
Oh, wow.
The word Pennine means mountain.
I learned something else today. I learned bijective, surjective, and now Pennine. Wow, so many things. Is that where
here we just build it through the mountains, and then we don't put guardrails so that if you're not paying attention, you just pop the edge.
You may.
Sorry, just that corrects me. We also have a Scarborough in Canada. Yeah, there's many places named after Britain. Seeing as Canada is our country.
It was part of the Commonwealth. Still is probably, right? Is it?
Is yeah.
It is part of the
same head
Commonwealth.
of state.
Yeah, still had to say it, yeah. But nice job, Lucky Cat. Great question. Give you a bond coin.
Yeah, I only found out recently that they changed the flag to that god awful maple leaf.
Really?
Not in my lifetime, but like reasonably recently.
Wait, you don't like you didn't know this was the flag of Canada?
No, they hate it.
Oh, they don't like it. The Canadians don't like this? They don't like this flag?
Well, because millions of people died under the old flag, and they went, no, we're not changing our flag for the fucking French.
What was the old Canada?
I was gonna say, I thought Canada was French for a while.
Canada, there was French Canada.
Well,
There's
I don't know.
Quebec.
I just know that I avoid
Quebec-
Canada
Quebec is
because
French.
there's a lot of French people.
Quebecois. There's a really cool Quebecois streamer on Twitch. I love how like Quebecois is just like it's like dirty
XQC.
French. Is
his name
XQC Quebecois? No, I'm thinking of this
Yeah.
this girl. Her name's Uchi or something. Uchi Quebecois streamer. Someone gifted me a sub to her or something. This chick. Yeah, she's hilarious, dude.
I don't know that.
Man. Or her name is Uchi? Is it Uchi? What is her name? Why can't I just like sorry, URFIEE. URFIEE Twitch. She's hilarious though.
Don't know who that is. And I usually know who people are.
Yeah. Okay. Is that where you're going? No, JC. I'm going to London. I'm flying to London, and then I'm flying over to Galway in Ireland, and then I'm flying out of Dublin. So, be bouncing around a little bit.
Wait, you go into Galway and then you're flying out. Oh yeah, that makes sense.
Yeah. Right. Yeah. Because the wedding's in Killarney. So, I figured I'll get to the west side of Ireland
West Coast.
first.
Yeah, I was going to say, why is it on the West Coast?
And then I'll pop down to the wedding, and then I'll take whatever the train or whatever the shit back to the east side of Ireland. And then I'll fly out from Dublin because that's the only flights to LAX really.
Well, it's just the reason I bring it up is because it's odd because even for the English, the British, we're aware that that coast of Ireland is populated by the Irish, for lack of a better way to describe it.
The Irish.
Sorry, so I should explain. So, the United Kingdom was at one point historically filled with Celts, and so we all spoke Celtic languages, and then the Angles moved in, and the Saxons moved in. No, this was after the Romans moved in, but anyway, the point is, the further away you get from London, the more likely it is that someone will be speaking a Celtic language rather than English.
Right. And that kind of like where Welsh comes from. Isn't Welsh like kind of Celtic?
Welsh is Celtic as well, yeah.
Yeah.
But it's a different Celtic.
Different Celtic. All right, let me see. Jeff, you picked this one with your me first. I will respect it. Okay. It says, consider the function f0 to infinity. Again, this funny thing, which I think is like map 2, but whatever. This is the domain. This is the range. Square root of x, log base e of x, minus x plus 1. Which of the following statements is true? Is only one of them true? I guess maybe only one of them is true. The derivative of the function. I think I could take the derivative of the function of this. Let's just do it, right? This is a good exercise in a little bit of calculus. So square root of x, and then log base e is ln of x. then minus x plus 1. You do have interesting questions. Okay. So let's figure out what f prime of x would be equal to. So this would end up being a product rule because you have two different things that you need to take derivatives of and they're multiplying each other. And so what we do is we take the derivative of the first thing, which I don't really like square root of x. I like writing it as like x to the 1/2 because then it's easier to see. Because this is 1/2 x to the minus 1/2 ln of x plus the derivative of this one, which is just 1 over x times the first without the derivative, and then that's going to be minus 1. Okay. So now I have 1 over 2 square root of x ln of x plus 1 over the square root of x, I guess, right? Because x to the 1/2 over x to the 1 is x to the minus 1/2, which is this. And then this is minus 1. So cool. There we go. That's the derivative. And then that's defined from 0 to infinity. Okay, so this can blow up. Right? This would blow up to positive infinity, but then this would blow up to negative infinity, actually, no? Huh. Yeah, okay, so that would, well, depends. I think square root of x grows faster than ln of x. Oh, I don't know. I think we would have to look at this using L'Hopital's, right?
I would, it would blow up to infinity, I believe. Because if you look at it as 2 to the negative 1, x to the negative 1/2, and then you move that to the exponential of your
I see.
what's it called?
Oh, you'd put that
your
inside the
natural
ln of
log.
x. Oh, that's
Then
actually
you
really
get
clever.
Basically an infinity to infinity, and that's going to blow up to infinity.
Oh, this is very clever. Breskels is very clever here. Yeah, okay. Breskels is saying if I were to write this as everything to the negative 1/2 ln of x, I know from my log rules, anything being
just to the
multiplied.
negative 1,
Sorry, just the negative 1.
because you're
Yeah.
just
I already have the
you
square
already
root
have
taken
your
care of.
exponentials.
Right.
Yeah.
Yeah. Anytime you have something multiplying by a log, I can always just bring that thing up top into the exponent. So that's ln of x to the 1 over 2 square root of x, right? That's how we would see that. And as x goes to 0, that would be infinity. This is still 0 to the infinity, though.
Oh, actually, yeah, that's still indeterminate. Think about it.
Yeah, it's still indeterminate.
So,
I
yeah,
can't do that.
you would just use L'Hopital's in that
Let's just
case.
use L'Hopital's rule. This is easy, right? Ln of x is going to go to negative infinity, and then we're going to say, I guess 1 over 2 root x. Well, no, fuck, I can't do that. Right? Because this is going to, as x goes to 0, oh, man. This is going to go to negative infinity. This is going to go to 0. Oh, so it's still just negative infinity. Yeah. Okay, that's fine. Yeah, that's fine. They don't ask us for the limit, but I think they were saying, okay, here we go. The derivative of the function is decreasing in the interval of 0 to 1. Oh. Well, then now we got to take another derivative
You're not that guy, pal. Trust me.
to figure out
You're
whether it's
not that guy.
decreasing, right? Oh, that's kind of annoying. Oh, I don't really want to do that. I hope you like my questions from Hello Partwise, reason being it would be easier to remember in the future. I don't know what that means. Okay. So wait, this is another like derivative I gotta do. Oh, this is ugly. Okay. This is negative 1/2 x to the negative 3/2, and then this is 0. But then this is another product rule. I got AP Physics C Mechanic exam, 1 day left to study. Any suggestions? I didn't touch the material, by the way. Uh-oh.
Oh no.
I love the people that think I'm Jesus and we can just like resuscitate and like turn water into wine. If you haven't touched the material and you have the exam, go cancel the exam.
If you haven't been studying, you're fucked forever.
Oh no.
You're fucked for the time being, I guess.
Hell, man. What the fuck, man?
Well, no, because it's like you know that there's an exam coming up, and it's like, oh, should I study like 6 months in advance? I don't fucking know.
I don't fucking know. Yeah. All right, here, 1 sec. This is x in the 3/2, ln of x, and then this is gonna be.
I think I see what we can do here.
Do you see it?
We get rid of the negative 1. Negative 1 doesn't matter, right? If we just ignore that. But if we factor out our 1 over square root of x to the outside, and then
Are you talking
bring
about
the
this?
1/2 in. Yeah, factor
Okay,
out
let's
a
try
1
that.
over root x,
All right, let's
bring
do
a
it.
1/2 in, and then we can just figure out if ln of square root x grows faster than 1 over root x decreases.
Oh, I see. Because yeah, I don't really care about the -1, right? That's a constant. Okay. I see. And so now you're just looking at this, saying, okay, yeah, does this grow faster than this? Right. Okay. So I want to say the limit as x approaches infinity of ln of x over the square root of x. That's infinity over infinity. And then
Be on the bounds of 0 to 1, right?
oh, sorry, just from 0 to 1. Okay. Well,
And so we just want to know if on 0 to 1 does ln of x grow faster than 1 over square root x decreases. Right, because if the magnitude of change from the 1 over square root of x is greater than the magnitude of change from ln x, it's decreasing. But if ln x grows faster than 1 over square root x decreases, then it's increasing.
I agree. Okay. So I think I still do L'Hopital's then, right? Just to kind of like see the end. Well, no, because we don't have infinity over infinity though. Oh, you already did good in a few exams and good. Then you're fine. If you're already doing great on the exams, then just do more practice exams. You'll be fine. Dr. Gold, can you react to an IG reel I made? Yeah, send me a DM. I'll do it. I think I still. I don't know how to see like which one's going faster though.
Or
Breasticles.
also we could just do another product rule. This one wouldn't be that
I think
bad
that's
of
what
a
I think that's what I
product
have to do. I think I just have to do another derivative here. So then this is -1/2 x to the -3/2 ln of x over 2 plus 1. And then it's plus 1 over the square root of x. And then this is just going to be 1 over 2x, right? Yeah. Cool. And then, so what is that? So that's going to be -1/4 ln of x over x to the 3/2 minus 1/2 1 over x to the 3/2. Oh, this is just so ugly.
Disqualified.
Okay, and then this is plus 1/2 x to the 3/2. Oh, okay, so maybe this cancels with this at least. Okay, cool. Yeah, I think we can just cancel that. I found a 3-hour YouTube video that covers the entire material. Yeah, if it's flipping physics, it's probably a good idea. Yeah, go through his stuff. The best way to study is to do, though. It's called passive learning if you just keep watching videos on shit. It's better than nothing, but I think the best way to study is to do things. And so I would just do more tests. Okay, let's think about this. From 0 to 1, this is always going to be negative, right, Breasticles? Because ln of x will always be negative from 0 to 1.
Yeah, that would be negative.
So from 0 to 1, ln of x is always less than 0. And then...
So it's increasing.
So, exactly.
That's positive.
Yes, so f double prime of x is positive, so it's always increasing. So that statement's false.
Disqualified.
Okay, so we found that. We found that this is wrong. Great. Local max and local min. I think we have to determine where this is equal to 0, right? And then we have to determine if the sign of it is changing. So okay, in order for f prime of x to equal to 0, I need 1 over root x ln of x over 2 plus 1 to equal to 1. So, okay, whatever. Let's do this. Ln of x over 2 plus 1 is equal to root x. Is there an easy way to do this? I think I just have to square both sides, right? It's kind of annoying. Or I could use Desmos. Like, fuck this, dude. Yeah, I'm just using Desmos.
Move the 1 over exponentiate.
Yeah, I just don't want to do it. Because then I still have to do an e to the and stuff, right? It just sucks. This is where
But I don't think e to the. I don't think we'll ever give you a 0
Okay, maybe.
on the at least on the real numbers.
Right. Okay, ln of x.
Because if you move the 1 over, you get square root of x minus 1 all multiplied by 2 exponentiate, and you'd get x. Oh, but then you still have an x in there.
They do intersect.
No problem.
They intersect right here at 1, 1. No fucking shit. Oh, that does make sense actually. Right, watch. We should have seen that. So at x equals 1.
Oh,
Right?
shit,
ln of 1 is
yeah.
0. I should have seen that. Okay, so x equals 1. Cool. Okay, so then I need to determine what happens to the derivative before 1 and after 1. That's the big question here. So, before 1, it's going to go from... This is going to be a really negative number, right? So I think it's going to go from negative if it's... Because think about if this was 0, right? And then after 1, this is positive, and then plus 1, minus 1. Okay, so it goes from down to this to positive, so it's a min. I think there's a local minimum. You tell me if it's answer choice C. I think it is. I think that's what it is. I can throw this at chat real quick. Man, oh man, this queue has gotten quite long, and I don't have much time today.
It's because of all those positive game marathons.
Marichods. Okay. I think the answer choices here is C. If you really wanted to just figure this out, you just graph this. The true statement is D. Okay, one sec here. What the fuck is this thing doing, dude? Critical points happen. Yes, let t equal square root of x equals t squared. Dude, what are they doing here, dude? What, excuse me, what? Yeah, t equals 1, at x equals 1, great. Now check whether it's a max or a min. For all positive t, sorry, why are they doing this substitution with t? I don't think you need to do the substitution with t. Yeah. Well, which one's wrong, Kaushi Techno? Me or ChatGPT? It's not increasing on the other side. I know it's definitely decreasing. I know it was decreasing on the left. But then the question is, when x is greater than 1, this will definitely be positive, man. There's no way. Right? Or is it because ln of x grows slower than square root of x? So eventually you get, well, no. No.
I do think it would be a global maximum. Because ln of x is going to grow really slow, so if you look at your original function, that minus x is going to decrease a lot faster, I think, than that ln of x root x.
Yeah.
And it's asking about a local max and local min rather
well,
than
I think there's
global.
a local min there. I think there's a local min there.
There might be. Chat may be wrong.
Chat could be wrong. Let's just graph this. Square root of x times ln of x. Right? Okay, there you go. I'm already seeing a minimum. ln of x minus x. Oh, uh-oh, there's a problem. Yeah, okay. Yeah, it goes. So look, it goes from decreasing, I agree, to flat, and then it's decreasing afterwards. Okay. So we're saying that this, when x is greater than 1, is still negative. Which intuitively I didn't think it was, because I saw like I think I see what happens here. Okay, so you have ln of x over 2 root x plus 1 over root x minus 1, and we want to know what's happening to that if x is greater than 1. So what's the limit of, I don't know, like as x approaches 2 maybe. Yeah. I see. This is, let me just see what this is. ln of 2 over 2 root 2 plus 1 over root 2 minus 1. That'll tell us real quick whether it's negative or not.
It's.
You think that's negative? I thought it was positive, but I think maybe it's negative. All right. Where's my calculator? All right. ln of 2.
Oh, actually, yeah, it might be negative.
Yeah. Right. It's
Now
sneaky,
that I think about it,
dude.
because of 1 over root 2.
The 1 over root 2 is gonna fuck with it. Yeah.
I was thinking root 2 is greater than 1. It's like,
Yeah.
it's greater than
No.
1.
And then this is plus 1 divided by root 2. Yeah. I just saw it intuitively and I was like, okay, cool. And look at this. It's close, dude. It's so close. 0.95 minus 1 is going to be point. Okay, cool. All right, fine. So, yes, correct. I looked at it and I was just eyeballing it. I'm like, bro, this has to be greater than 1. It's not. It does that. So, yeah, the function neither has a point of local maximum nor a point of local minimum. Answer choice is D. Yeah, cool. Oh, I should have marked that one as the one I was doing. Who is this? This is Hello Part 3? Okay, I'm going to say this was Kashiko. What's up, Hypersonic? I do need a drink. Okay. Let's mark that one as done. They said that question would only take 6 minutes. It was just kind of a pain. Because you're dealing with like ln of x and then like square root of x. They're all like kind of irrational functions, and trying to do algebra and compare them is annoying.
Oh no.
Anyways, okay. All right, let's go spin the wheel. Trying to help as much as we can. Let's go spin a winner.
Let's go gambling!
Megastician. Physics question. Difficulty 7 out of 10. What do you got for me? Oh, this is... Oh. Damped pendulums? Oh, this might be a little tricky. A spring of force constant 3 newtons per meter is connected between 2 identical simple pendulums, each of length 0.8. Calculate the period of the other pendulum if one is damped, taking the mass of each bob as that. What? Why?
Oh, dang it.
Why do people come up with these goofy ass situations, dude? What?
Actually, there's a larger why at play here as well. This is an engineering question.
You think it's engineering?
G equals 10. It's an engineering question.
Ooh, okay, yeah.
No, I think it. This
It
seems
could
like
be.
a Diffie Q one.
I think it's a Diffie Q.
No physics question would make that mistake. Or at
Exactly.
least not in the real world.
So that's why Diffie Q is probably doing it. He's right. It's probably a
Yeah,
math
I
question.
think it's Diffie Q. Like when I took it, they use like slugs and shit as the unit.
Dude, get out of here with the slugs, dude.
Which is engineering.
It's true.
Yeah, which
Yeah, I do think we have to solve this. This is weird because this is not standard physics, by the way. You have, yes, 2 pendulums, and these each have a mass equal to 0.8. And then calculate the period of the other pendulum if one is damped. What do you mean if one is damped by how much, though? What? Or sorry, the mass is equal to 0.23. And then, yeah, this has a length of 8. 0.8
Yeah,
meters.
this feels like an engine timing question, just disguised as something else.
Yeah, it's a wolf in sheep's clothing, dude.
Emotional, damn it!
This is not a standard physics question. Like, if we
could
had
just
just one
solve
of
it.
these things, I could figure it out. But this is fucking weird. Oh, man.
No, I can just sort of smell rotational timing coming off this question.
Yeah, well, so there is rotational motion or circular motion per se, because these things are gonna like move this in this direction. The weird thing though, is I mean, I guess we're assuming they move together at the same height, but dude, like what? Oh, man, y'all in the fucking question section sometimes, dude. What? Why? Okay. I'll write out some things I know. I know omega is equal to the square root of G over L for a pendulum. That's for a simple pendulum that's just moving back and forth. But then you also have what I guess is a restorative force, and this is the restorative force due to gravity. So for instance, when a pendulum oscillates from being from here to here, what's happening is gravity is providing a restorative force down at all points, which is causing this, again, to oscillate with simple harmonic motion. As such, what makes this even more complicated is, in addition to gravity providing a restorative force, I now also have an interaction that there's a spring between these two things that is going to exert a force that's proportional to the distance between the two. So this is where I agree with Breasticles that you probably need some sort of differential equation to get to mess around, I guess, with the forces, and then somehow solve that for the general solution, which would be the position, right?
Yeah, that's what my first thought would be. Like, it seems like a DiffyQ question in the sense that I think you would want to start by saying that MA or MX double prime is equal to your negative KX, and then incorporate the damping from the pendulum.
But also, like, what is the damping? Sorry, they say one is damped, but like by how much? Is there's usually a damping factor, right? Like, because there's critically damped, right? There's underdamped, and then there's like overdamped. Like, it just says one is damped. Like, what?
I'm not really sure.
I'm not really sure what they're doing here. Okay, this one's going to chat. Also, what did my thing think it was difficulty wise? Said it only a 7 out of 10. Clear single physics calculation involved coupled pendulums and period determination. Yeah. You never understood the notion of damping. Damping is cool. So damping is just it's like friction. It's something that robs energy away from simple harmonic motion, and the extent to which it robs it can be classified as either being critically damped, overdamped, or underdamped. And if there's probably a cool diagram of this. Let me think. Hyperphysics. One second. Let me just throw this question in the chat, and like we'll have chat solve it while I go explain damping, because damping is cool.
Basically, add oil.
Add oil. Yeah. Oil.
A lubricant of some kind.
Yeah. Here we go. So,
WD-40.
WD-40. Yeah, we love WD-40. Okay, here we go. This is the... And yet what?
No one can remember what it means.
Oh, is it one of those things where we've lost the meaning of it, kind of like Hoover and like
Well, no, I know what WD-40 stands for, but very few people remember.
What does it stand for? Enlighten us.
Water displacement.
Ah. Because it is an oil, right? Yeah, and it does displace water. That is true. Here, let me grab this image. Graph is cool, but still not explaining classical physics. Okay, well, eventually when it comes down to solving a differential equation, it depends on like whether your omega has imaginary terms in it or not. And so, okay, if something is underdamped, so if something is undamped, you would have motion that would continue sinusoidally forever, right? And that would be great. Okay.
I think I figured it out, by the way. It had to use the help of chat, but I think I
okay.
Understand now.
Nice. So that's so with zero damping, something just oscillates back and forth, and because there's no energy being taken out of the system, it's free to keep hitting the same amplitude and oscillating forever and ever. However, that's not how the real world works. You have things like air resistance, you have friction in whatever the axle and stuff, and so you get damping. And damping is like friction when you're like pushing something across a surface. It robs energy from the motion, and the rate at which it robs the energy falls into some different domains. If it's robbing it like just a little bit, then what will happen is this thing will oscillate, but the amplitude of it will decrease in kind of a negative exponential. Yeah, so losing force, exactly. Right, and the reason this comes from, right, so with springs, right, F is equal to kx. This is the restoring force of a spring. Which is why, if you have something here, right, when it goes from like the far end to like the pushed in end and stuff, those are where delta x is the biggest, and so the restoring force is the greatest. But if you have any sort of friction, or in this case like damping, which is robbing kinetic energy from this thing moving back and forth, now you're no longer able to reach the extremes for delta x that you were at the beginning of the oscillation. And so what that does is it eventually just like decreases the amplitude.
Shouldn't it be a negative kx?
Correct. Yeah. I always just say kx and it's just pointing the other direction, but you're correct. It is negative. So a bouncing ball has damping. Yeah, a bouncy ball has damping because every time it collides, it loses energy due to the deformation of the ball, and there is friction. Also, there's air resistance, right? Air is a fluid, and as you move through a fluid, you bounce into particles of the fluid, and those eventually decrease the amount of speed that you have. So yes, bouncy balls do that. So yeah, this is a good example. A bouncy ball that bounces a couple times and eventually stops, that's underdamped because it's not killing it off yet. The next thing you have is called critical damping. Critical damping is where is the minimum amount of damping you need in order for it to not make any oscillations and just stop. Okay? How I like to think about this is if you had like a door that was like swinging back and forth because it was on a spring or something, but somehow there was enough friction such that once, or not even the door, let's say the spring. So let's say the spring starts out here, right? And it wants to come back in. If you have enough damping, enough friction such that this thing loses all its energy before it can overcorrect itself, right? Before it goes past this point and then starts building energy to go back the other direction, that's critical damping. So it's having enough, like a ball of straps in those games where you have to put a cloth in the hole. What is this, like a Mormon like wedding thing? What? Excuse, what? Put a cloth in a hole? Balls of straps. I don't know what this game is. You can send me the link to the game. I've never heard of it. But anyways, yeah. So that's critical damping. Is it slows down and stops right as it hits equilibrium. Over damping is when you like really hit this thing with so much damping that it takes a very, very long time to even, if it even does hit equilibrium. So that's the difference between all the different dampings. All right, so let's see. Breasticles, you looked at the solution for this one?
Yeah, I get what they did now. It took me a second, but I understand.
I see. So yeah, this is what I said, right? Omega is equal to square root of G over L. I had that. That's just for like a regular pendulum. And then the spring force for small oscillations has a horizontal displacement. Okay, wow. They use the small angle approximation. They're going to say that delta x is equal to L theta. Okay, so they're saying that as this pendulum moves, let's say a small distance to the right. It's actually kind of cool. So let's say the pendulum oscillates a little bit to the right. That this difference in the distance So let me get rid of this. This right here is technically equal to L theta. The reason for this, technically, if this thing starts bobbing off to the right, it's going to move up a little bit. And so it actually doesn't look like a nice perfect thing here. But we say that, okay, cool, well, let's assume it moves a small amount horizontally such that there is no real change in the vertical displacement. And then the amount that it displaces angularly would be theta. And so this amount would be, if this was L, would be L sine theta. But then physics loves to do this where we say, oh, but if theta is much less than 1, then L sine theta is the same thing as just L theta. Or sine theta goes to theta. Does there exist a motor with positive damping? Yeah, I mean, it's called just a driven motor. Yeah, that's positive damping. 2 sine theta over 2? Why are you saying 2 sine theta over 2, Jeff?
My name is Jeff.
Okay, so they're calling this displacement L theta. Again, these are kind of some bastardy, like, approximations. And then the force, so the restoring force, oh, because it's an isosceles triangle. Oh, I see. Yeah, you're talking about this. I see. Jeff saying that this distance right here would be 2 sine theta over 2. Correct. But then from that, we only care about the horizontal displacement, which is, I think, where it just ends up becoming L times theta.
Yeah, they did it similarly on the GPT I used, but instead they just went straight to the force from the pendulum would be a negative mg over L times x, from a small angle approximation of sine theta being almost theta, or almost x at small angles.
Yeah.
And then just minus kx, and then they just factored it, and that's omega, and then solved using period.
What's K? K is a spring constant. It's how stretchy or how stiff the spring is. Then they did torque from the spring, which is K L squared theta. Okay. Oh, I see. Because it's okay. Torque. Okay, so this is the force of the spring. So then torque is equal to R cross F. So in that case, that would be equal to, negative K. That would be equal to L times negative K L theta. So that's equal to, negative K L squared theta. And then torque is also equal to I times alpha. Oh, here's my alphas again. But alpha is the angular acceleration, which is the second derivative of angle, of theta. So you get I double theta is equal to negative K L squared theta. Negative K L squared theta. Okay, I think we're getting closer. And then, okay, and then I for a point mass, right, is ml squared. I guess we're assuming that the pendulum is no, that would be a shitty spring. Yeah, 3 is quite terrible for a spring. Usually springs are like a couple thousand. I see. We're assuming it's a massless pendulum, or like the length of the wire is massless. So if it's a point mass, I is equal to ml squared. So ml squared theta dot. So this is for a point mass. Is equal to negative K L squared theta. Where have we dealt with gravity yet, though? Oh, I see. And then here's the mgl theta. Negative mgl theta. Oh, okay. Yeah, wait, where did the negative mgl theta come from? I think that comes from this. So if the pendulum is over to the right, then there's a force of gravity pointing straight down. And so some component of that, I guess, is trying to restore it back. And so, yeah, that would be mg, and then if that's L, then that's sine theta. Yeah, that's funny. It is constant for certain springs, disinfants. Yeah, here, and then let me get a picture of this. It's a very involved question. It's cool, though. For it, not for a spring, for a pendulum. Theta is much less than 1, yeah. Yeah, here we go. Okay, this is like the force diagram for a pendulum. So what happens is, again, you have something that's oscillating with simple harmonic motion to the left and the right like this. And so when it's at some distance displaced away from its equilibrium, where it's just like chilling, you have mg pointing down, and then there's two components of that. There's a component that's trying to restore it back, and then there's a component that's normal to that. The component that's trying to, of the force that's trying to pull it back, is equal to mg sine theta, because this is mg, this is theta, so then this part right here is mg sine theta. And then what we're going to say, okay, and then we're going to say this is also minus mg L sine theta, I guess, right? Yeah, minus, oh, that, because that's the force, but then this is a length L. Oh, I see. So the torque from gravity, so you have mg sine theta times L, and then this is the torque from gravity. Yeah, so tension in the spring, tension in the rope there would be equal to mg cosine theta. Okay. And then again, you say that theta is much less than 1. So sine theta equals theta. And then you get to this. ml squared theta double dot is equal to negative KL squared minus MGL all times theta. I think that's what they had. Yeah. MGL theta plus KL squared. I think that's what we had. Oh, they put a plus on it? Oh, no, the minus is outside both of them. Yeah, okay, cool. All right, nice. And then, yeah, Brasicles, you're right. This is going to be a differential equation. It's actually a very simple differential equation, right? Yeah, this is a super simple one.
But
Yeah.
we don't even need to solve it. We can just pull omega straight from it.
Right, exactly. Yeah. So this is negative KL squared plus MGL with parentheses around this. And then this is divided by ML squared. And then the classic one you learn for a spring, for instance, let's just say for a regular spring like this. Okay. Yes, an oscillator is a differential equation. It's a very simple one, though. So consider you just had an object that was on a spring that was stretched out. The restoring force would be equal to negative kx. And then we know from Newton's laws that the sum of the forces is equal to mass times acceleration, but acceleration is the second derivative of position. So then you get mx double dot is equal to negative kx. Divide by the m. X double dot is equal to negative k over m times x. And then this part right here is called omega squared. Because the solution for this is that x is equal to, I think it's, is it just sine omega t, right?
Yeah, kind of.
Yeah, it is.
You could just say sine omega t, but sometimes if you're in like a math course, you'll want the full
C1,
x
C2 shit.
equals C1, C2, sine omega t plus cosine omega t. Which, depending on your omega, normally the cosine and the sine just evaluate to either 0 or 1.
Yeah,
respectively.
exactly. Just based on what your boundary conditions are. So we take the intuition for simple harmonic motion. So when you have an x double dot is equal to something, and then it's just times the thing without the double dot. Whatever is here is called the frequency. And so this right here, so I would say that omega squared is equal to all of this. Okay, cool. And then what was the question actually asking for? Why did I label it omega squared? Because when you have a differential equation that looks, again, like some displacement second derivative is equal to some coefficient in front of it times just the displacement, we call this thing omega squared because in the solution for this, x is equal to sine omega t, this is called the angular frequency. So, and you can if you wanted to do this, you could figure out what the second derivative is. You get the second derivative is equal to what would that be? That would be omega squared, negative omega squared sine omega t. Yeah. This is the general solution, or one of the general solutions to this differential equation. What is angular frequency? Yeah. Now we're getting into like what angular frequency is, just the rate at which things oscillate back and forth, basically, in some sort of angular fashion. So it could be like a wheel going around, or it could be something making a cycle. So in this case, going from the starting of the pendulum to the other side and then coming back. That's also called angular frequency.
Dude, if you don't understand...
Yeah, it's okay. It's okay to ask those questions if they don't know. If they don't know, it's okay. I know sensation.
Right, but like angular frequency is descriptive.
Yes.
If you don't know what angular frequency is, you don't know English. It is angular. It is a frequency. It's not open to interpretation.
I get it. Yeah. So from the words, sensation is right. You could kind of decide that it is like the frequency at which angles happen, but I agree that there is a little bit of a nuance to it, because it really means how many times per second a cycle happens, and a cycle isn't always 360 degrees. So in the case of the pendulum, right, the one cycle is just going from here to here to here, and you're not traversing 360 degrees when you're doing that. In the case of a wheel, then yes, it's the amount of time that you're traversing one full revolution, or the amount of revolutions you travel in 1 second. Okay, anyways.
Actually, interestingly enough,
unrelated.
Unrelated, what's
I
up?
was just say, unrelated, should be no negatives on the frequency.
Perfect.
Omega,
yes, thank you.
The
thank
omega
you.
squared.
Yep, you're right. You're right, because it's negative omega squared. Okay, cool. Sorry. All right. Okay, so that's omega.
In pure maths, pendulums rotate 360 degrees, which I always found counterintuitive. I just assumed that the pendulum would only swing 180 degrees.
If it went all the way from horizontal to always to horizontal, you're right. In this case, we're we're making a lot of assumptions, and one of them is that the amount it swings is actually very small in terms of angle. That's the only reason we're allowed to say sine theta is theta, is because we're saying that the amount that it oscillates back and forth is small. This is called like the limit of small oscillations. Yeah. Okay. We're done with this. This is 2 pi over omega, and so you end up getting 1.24 seconds. Cool question. Very, it's very involved. There were a lot of like side topics we had to go into, and there were also a lot of approximations that you had to know to make. It's typical physics sometimes.
Yeah, that's part of why I think it might be diffy-Q. Because a lot of the time they'll just teach that the force from a pendulum is this, and the force from a spring is that, and then
right, and then you just plug it in.
To say, yeah, that F equals ma, and then the other F is the sum of your forces. Plug it in and figure it out.
Yeah, that was a cool question, Megastician. It scared me at first, and then this is a great example of where AI gave me enough confidence that I knew I was going down the right path with what we were doing, and I'm like, okay, which if I'm allowed to make these assumptions, then this becomes a much easier question to deal with. Because if we had to deal with the vertical displacement of the pendulum as well, this would become kind of a nightmare, honestly. But that one took 27 minutes. Lucky Cat says, me first. Wait, didn't we just do one of your questions, Lucky Cat? I should make a rule that you can't claim me first if we already did one of your questions today.
I don't think we did. I think we did.
Yeah, we did, because this was Lucky Cats. This was Lucky Cats, right? This was pineapples.
Oh yeah, it was. It was.
Yeah. Okay. Let me just see. Because I don't have much time today. I have to pack. I'm leaving in less than 12 hours now. Implicit differentiation, you like it. Yeah. Let me see. I'm gonna spin the wheel at least once before I do another me first.
Let's go gambling!
I'm done with questions. I don't speak English anyways. Oh goodness, and fonts. I hope it was helpful. Yeah. It's always okay to ask questions. Dissonant infants. You know. We'll sometimes be like a little tough love on things to see from it, but you're okay. You're okay, man. All right, let's see. What do we got? This is Ace's question. Balance the... Oh, I love redox. JC, we're doing chemistry now. Chemistry. All right. Balance the following redox equation. Be sure to show all your work steps and identify what's being oxidized and what is being reduced. Okay. And then you started adding stuff. I guess you do need to do that. Oh, this is the key thing. They also say, like, it's in an acidic solution. So when something is in an acidic solution, you can add H plus and H2O as necessary, is what we say. Okay. So let's see what we got. Yeah, what's up, DeGilman? Yeah, these are fun, actually, right? Okay. So I have MnO4. I'm not gonna look at what they have for the answers. I'm just gonna do it my way. So 3Mn. Sorry, I'm not gonna put the 3 on it. So Mn2 plus, right? And then that's gonna go to MnO2. All right. I think first thing I want to do is try to balance the Mn's, right? So, and I believe the H's and stuff as much as we can. But yeah, let's look at what you want to figure out first is what the oxidation numbers are. So each oxygen is almost always -2. And then because you have 4 of these, that gives you a total of -8 from the oxygens, is what I would say. So here, this is how I would kind of write this. If I wanted to like color code it, I would say oxygen is usually -2. And because you have 4 of them, that gives you a total of -8. But then overall, this whole thing has to have an overall charge of -1. So if I already have -8 plus from here, that means this must be +7. Such that now overall +7 and -8 gives you -1. So here, if I were to color code it, let me just show you how this would work. Kind of cool. So here, we would say this is Mn. You kind of like work backwards from things. Okay. So this would be +7. All right. So this is going to be, we're going to call this, I think we call this ionic charge. And then I would say total charge. And then I would call this like total overall charge. And overall, you need it to be -1. This one's easy. I already know this is just a +2 because there's only one of them, and they already tell us it's +2. Okay. Then you get to here. This is also again oxygen, which is usually going to be a -2. So you're going to have -2 from the oxygen, but then you have 2 of them. So that makes it -4. And then I don't know what Mn is, but I know overall it has to be neutral. Right? Overall, this charge has to be neutral. So that tells me, working backwards, that the Mn had to be a +4 as well. Okay, so then this is just going to be +4. So that's kind of how you do it. You do this, you look at what the overall charge is, and then you work backwards to find out what the other, it's called the cation, is attached to it, what it would be. Okay. So then, this is interesting, because we have manganese, I think, actually being oxidized and reduced. Right? You have manganese here going from +7 to +4. That's going to be a reduction because it's a gain of electrons. It's a gain of negativity. It's a loss of positivity. What's up, Gladiator? And then you also have manganese going from +2 to +4. That's an oxidation because it's a loss of electrons, which means it becomes more positive. So interesting. I think there's 2 things here. I think oxidized. You have an this is the key thing here we learn, which is oil rig. So oxidation is loss, reduction is gain, and that's gain of electrons. And so if you're gaining electrons, you're gaining more negativity, which means your charge is going down. So oxidized, this is losing negativity, which means you're getting more positive. That would be the Mn2 plus going to Mn4 plus. Okay. And then the reduction, which would be a gain of electrons, which means getting more negative. That's the Mn7 plus going to Mn4 plus. Crazy. Okay. I don't think I've really done these where you have the same thing being oxidized and reduced. Okay. We can think about the charges on things first off, because I have an overall charge of -1 here, an overall charge of +2 here, which means I need an overall charge of either +1 over here or I need 0 over here. You want the charges to balance on both sides. Usually these half reactions would kind of show me what to do, but the issue here is that we're sharing this as the same fucking thing. Damn. Okay, let me think. I think this is what happens. Let's try to balance the charges here. So going from 2 plus to 4 plus, this means there must have been an extra 2 electrons here in order for charges to balance. And then going from 7 plus to 4 plus, move this down. That means you must have 3 electrons. 3 electrons from here. Okay. Now, what I want to do is I want there to be the same number of electrons on the left and the right, so you have to find like a common denominator between these. So I think I'm going to multiply all of this by 3 to get 6. And then I'm going to multiply all of this by 2. And then watch what you get. So this will get me 3. These are called like the half reactions. So I'm going to get 3 Mn2 plus is going to 3 Mn4 plus 6E minus. And that that was the Mn2 plus was just chilling from here. And then this is technically Mn4 plus O2. This is technically the O2. And then from this one, I'm going to have 6E minus plus 2 Mn7 plus. And then the Mn7 plus had an O4 on it, so I'll say Mn7 plus O4 minus. And that's going to go to 2 Mn4 plus O2 plus, and then that's it. Okay, so here's the cool thing. So this gave me this one. This gave me this one. Now you add them. Just add the reactions together. And you'll see some cool things. So so we have 3 Mn2 plus. I'm going to have 2 Mn7 plus O4 minus. And then this is going to go to 3 Mn4 plus O2, 2 Mn4 O2. So this is going to be 5 Mn4 plus O2. But then we usually get rid of this notation. We don't put what the ionic charges are on things at the end. So I'm going to leave like that. That's going to leave like that. And so this should be our balanced reaction in terms of charge. And let's see if it's balanced in terms of MNs, right? 2 MNs, 3 MNs, 5 MNs, good. This is where things are going to get weird. I have 8 oxygens here, but I have 10 oxygens here. So I need 2 more oxygens. The way to get that is to add water and H2Os. Sorry, water and H pluses because it's acidic. So now I need to balance oxygen and hydrogen with H2O and H plus. And so the way to do that, if I have 8 oxygens here, I got 10 oxygens here, I'm gonna have to add 2 H2Os over here. So I'm gonna say plus 2 H2O, all of this. And then that's going to go to 5 MnO2. Okay, so now the oxygens are balanced, but the hydrogens are not, because now I have 4 hydrogens, and I don't have 4 hydrogens over here. So then this is, because it's an acidic solution, I can put as many H pluses as I want on either side. So I'm going to put 4 H pluses over here. Yeah. And I think that's it. Let's see. Yeah, and that's what they have. Look, 2 H2O, 4 H pluses, 2, 3, 5. Wow. Okay, cool. Yeah, there. We got it. And then this is the final answer. Nice. Cool question. Tricky question, though. This is like the most math-heavy part of chemistry. At least intro chem. Doing all this. If you have any questions about it, I could explain the steps, but in general, you want to get the half reactions first. And the way to get the half reactions is to figure out the ionic charges on things, so you know what's being oxidized, what's being reduced. Then you need to balance the charges on each of the half reactions. Then you need to multiply each of the half reactions by some number so that you get a common denominator for the number of electrons. Because what happened here is 3 times 2 gave me 6 electrons here on the right, and then 2 times 3 gave me 6 electrons here on the left, and those cancel out. So that now when I add the 2 half reactions together, I get the full reaction. And now this is balanced in terms of charge. Or in terms of exchanging electrons. The last thing we need to do is to balance the hydrogens and oxygens, and we do that by adding H2Os and H pluses. And then I think this is balanced in terms of charge. Actually, I guess it's not, right? Because this is -1 and plus 2, so that's +1, and this is 4 plus. Yeah, I think as long as the half reactions are balanced. Redox, yeah. Chemistry.
Good
Okay, cool. I'm gonna mark this one as done. This one probably took a while, honestly. But cool question, Ace. Yeah, oh, only took me 13 minutes actually. Not bad. It felt longer, just because it was more tedious, I guess. Chat thought I could do it in 8. I mean, I guess if I didn't explain any of it, sure. But okay, any of these questions, if you ever want to go back through and figure out like what we did, we post everything in our Discord. So if you go to our website, actualofficehours.com, and click join our Discord, in our Discord, there's a channel here called Homework Help, and every question we do gets put in as a post. And so there's also a link here to rewatch the the play-by-play of the live stream. Okay, cool. And oh, this was what they had. Oh, thank you for that. Let me post that in for Mega Stitch as well. Okay, all right. Lucky Cat, you did redeem me first. I will allow it this time. This is cool. I think this is gonna be just because you have an exam tomorrow. It's okay. I'll give it to you. Okay, consider the curve with this equation. Determine the exact coordinates of the points on the curve such that the slope of the tangent curve is 1. Always remember, anytime you see slope, tangent line, whatever, so slope of tangent line is equal to derivative. Just always write that down. I feel like this will help you out so many times in intro calc. So we need the slope of the tangent line, which is equal to 1. And the derivative is going to be dy dx, which in this case is df dx. So, and then they want the exact coordinates of the point. Okay, cool. So I think we take this. So df dx is equal to ddx of 1/4 x to the quarter plus... They made this a nice one for us, didn't they? Minus 2x squared minus 3x. Let's take the derivative of that. That's going to be equal to... 4 comes down, and then we drop the power, so that's x to the third plus x squared minus 4x minus 3. And then I need this all to be equal to 1. Oh, man. Oh, I know what I'm going to do. I'm going to move this over such that this is x cubed plus x squared minus 4x minus 4 is equal to 0. So we're just going to move that over with like a minus 1. And now you can group. Anytime you got like 4 terms, this is where you usually want to like try to like factor something out of both of them. So I'm going to factor an x out of this one, or an x squared. So if I factor out x squared, I'm going to get x plus 1. And then from this one, so from this whole mumbo jumbo, I'm going to factor out a minus 4. And I'm going to say minus 4 x plus 1 equal to 0. Let me like show you how I did that. Yeah. Very cool. And so now these two things factor out to x plus 1. And then this factors out to x squared minus 4. And now these are multiplying to be equal to 0. This is where this is really cool, because this would have been a pain to solve this. But if you can get it into factors that are multiplying each other, now all I need to do is figure out, oh, where does this thing equal 0? And where does this thing equal 0? Because if either one of those equal to 0, multiplying the two together will also get you 0. So this happens at x equals negative 1, and then this equals at x is equal to plus or minus 2. So, in fact, yeah, the points are, yeah, so points are, x equals -2, x equals -1, and x equals +2. And then you just need to plug them back in to here. And I'm not going to do that because that takes time. But then take those x points and plug them in, and then you'll get the y. Nice. Cool question.
Well done! Well done!
Certainly did. There we go. Okay, I got like 5 minutes. 3 minutes. Let's see what else we can do today. Spin the wheel. Who are we gonna get?
Sub-Zero
Let's
wins.
go gambling!
Fatality.
I gotta watch the new Mortal Kombat movie. I've been meaning to watch.
It did just come out, didn't it?
Oh, it did. Yeah. I think it came out on the 9th, I want to say.
Oh, look, more springs. More springs. I never played Mortal Kombat actually as a kid. I feel like it was a PlayStation only title, right? I didn't have a PlayStation.
No, it was on 360 too.
No.
Played.
Oh. I'm talking about
You're
like
both full of shit.
No,
you're both full of
it
shit.
was on. It was
Sega?
on
It's on Sega?
360.
It's on Sega? Was it on Sega? All right, Sensation, educate us. Educate us. Sensation is the resident like old school gamer knowledge expert.
It was on the Mega Drive as well, but it was on the Super Nintendo.
It was on the Super Nintendo. Oh wow. I only had an N64.
I have behind me a boxed copy of Mortal Kombat 2.
Oh, show it to us. Show the class. Come show the class. Let me see.
I can't reach it.
I can't reach it.
I can't reach it. Maybe next time.
Okay. Let's see. A toy car is on a smooth horizontal track. It's pushed against the free end of the spring. The spring compresses. The car is then released. The car accelerates to the right until the spring returns back to its original length. Oh, okay, cool. The car moves with simple harmonic motion as the spring returns to its... Wait, is the toy car... The car is released. The car accelerates to the right until the spring returns to its original length. So the car is always attached to the spring? Man, this poor car. It's just getting, like, knocked around, dude. The acceleration of the car is given by that. Yeah. Yep. Use the data below to calculate the time it takes for the spring to return to its original length after the car is released. Oh, okay. I guess there's two ways to do this. You could do this with kinematics if you wanted to, right? So one way to do this with kinematics. So here, you can do kinematics if you want. All the way, the acceleration is changing as a function of position. Uh-oh. Or I guess we could derive it. We could integrate it twice, no? Maybe. The real way to get this is to just get that omega is equal to k over m. So period square root of k over m, sorry. So period is equal to 2 pi square root of m over k. And then the period is the amount of time it takes to go from here to stretch all the way out at one end and then to come back. So the amount of time for it to just go to the uncompressed length, I think would be a quarter of that time, right? So if it starts here, it's eventually going to go here. So this would be, we would say like 1/2 of a period would be when the car goes from compressed to uncompressed to stretched, and then it would go back to come back to uncompressed and then to compressed. So yeah, so getting to here would be a quarter of the period. Yeah. So I think you just need this. So Okay, so you do 2 pi square root of 80 over 60. So square root of 4/3. So that's 2 pi square root of 4/3, which is equal to 4 pi over the square root of 3. And then t1/4 is equal to 1/4 of that. And so that would just be equal to pi over 3 seconds. Pretty easy. I wonder if there would be a more complicated way to do it with kinematics. I think the issue is that the acceleration is not constant. So yeah, the only way to really get this is to realize that it's simple harmonic motion, and that because it satisfies the differential equation where mx double dot is equal to negative kx, that this k over m is omega squared for that solution. It's kind of like a roundabout type thing. But okay, cool. There you go. MX. Kind of a cool one as well. Or MZ. MZ. Oh, you have Mortal Kombat for us? Let's see. Whoa. Whoa. Whoa, that's sick. That's really cool. For the SNES. You have a couple SNESs behind you, right? I think we saw some. Are they the ones behind you?
They're up back on the other shelf now.
Oh, okay. What's the ones behind you, though? Or right behind you? I remember seeing some, like, right behind you. Oh, they moved. Yeah, you had them right there. I do remember. You had them right in front of all the PlayStation titles. You had them right there, I thought. Yeah. They've moved. It's okay. Cool. Yeah, Sensation has a lot of dope, like, retro video game shit. Yeah, SNES box.
There's more money in retro video games than there is in cars.
There's more what?
There's more money in retro video games than there is in cars.
Yeah, you know they also talk about like Legos apparently go up in value. There's a thing called like a brick folio, right? Legos have like beaten the stock market, certain Lego boxes and stuff.
Well, if that were true, and let's say if, then there would be Lego shops in every town, village, and city in this country. There aren't Lego shops in every town, village. What there is retro video game shops in every town, village, and city in this country. I live in the middle of nowhere, and there's at least 5 directly around me. So that just goes to prove a point.
Yeah. Okay, let's see. I think I'm out of time. Yeah, it's past time. Okay, cool. All right, so let's close the stream. All right. Thank you, everyone, for coming to Actual Education Office Hours. I apologize. I had to have a shorter stream today. I have to pack. I'm going to Europe in less than 12 hours. So, but I appreciate all the questions you guys asked today. They were super fun. If I didn't get to your question, I apologize. Do not worry. We will do these when I get back. Or you can submit them when I get back. Some of these are like crazy. Dude, what? Someone was asking about this? What? Oh, man. This is a transistor is what this is. Calc 3 for Tuma. This would have probably been a good one. Yeah, partial.
Yeah, I threw that in there. That's not that bad.
I appreciate you doing that, Bresticles. I think it's really cool that Tuma wants to learn more like physics and Calc 3 over the summer. Now that they don't have to do it for like a grade, it's like for fun.
Yeah, it is helpful.
We'll do it. We'll do it. This looks kind of tricky though. What the value of 5 minus alpha squared is? Oh God, what was this? Dude?
Oh no!
I always love seeing like what people submit. And then yours, Bresticles, what was yours going to be? Ooh, I see. We were gonna do
infinite parts.
Oh, this is the infinite integration by parts.
Yeah, see how it's x negative x to the n as n goes to infinity. So you
and then it's e to the x
by using integration by parts.
Oh
so you
man!
Use a summation form of integration by parts, and then
so it's like infinite tabular method.
Kind of, yeah.
Oh, cool. Okay. Maybe we do that when I get back. Okay, cool. Well, I appreciate you all being here. Again, make sure go check out our website, actualofficehours.com, because this is the last stream for the month for me. I will be back June 1st. But if you ever want to see anyone else who's awesome in streaming and all our friends, go click on the streaming schedule on our website, and that will have all the different other streams that are happening. So looks like Zach's going to do some Diffie-Q stuff tomorrow. Penn Center's going to help out with homework. Zach's going to do some category theory on Thursday. Thank you, Gilman. And then Eric's another awesome grad student in math. Going to do some number theory and then more Q&A. And then looks like Justin's got a stream next week as well. So a lot of fun stuff on the calendar. Go check it out. Also, make sure to go join our Discord. That's where we organize all the events. We're going to be doing a lot during the summer. So a lot of like fun activities, summer camp. I will be teaching a class at UCLA that you guys are welcome to hop in on lectures and learn with. And I'll coordinate with Zach. Zach's coordinating a study group for that I will put out more information as we get closer. But that'll be mid-June, end of June. Okay, and then also, because we like streaming on Twitch and Twitch is awesome, we're going to go raid someone. So let's go say hi to another streamer. Support all the people doing math and science and all the future people that will be doing math and science. Who do we got? Who's on today? Shark Geek's doing stuff. Thank you, Zach. I appreciate it. Yeah. I will still be available on the Discord and things. I just won't be streaming for the next 2 weeks. Okay, I don't think we've said hi to Nerduino in a bit. Go say hi to Nerduino. Nerduino's great.
Tiananmen Square 1989.
I don't know what that means, Sensation. Okay, cool. All right. Let me see. I had it open for a second there. Sorry, my bad. I fucked up. There we go. Raid. Following. Nerduino. Where are you, Nerduino? I just saw you. There you are. Start raid. All right, we're already ready. Okay, cool. All right. Enjoy the rest of your week. We will see you when we get back in May. Peace.
We did fine.